don't pull on other objects. They warp the space around them. They bend it, curve it, distort the geometry. The apple isn't being pulled to the ground. It's following the straightest possible path through curved space-time. But space-time near Earth is curved, so straight points toward Earth's center. You, standing on the ground, aren't being pulled down. You're trying to follow your natural path through curved space-time, a path toward Earth's center. But the ground is in your way. The ground pushes you upward, preventing you from following that natural path. That's what you feel as weight, not gravity pulling down. The ground pushing up, deflecting you from your natural trajectory through curved space-time. Einstein made a concrete prediction. If gravity is really curved space-time, then light should be affected too. Light has no mass. In Newton's theory, gravity shouldn't affect light at all. But if gravity is curvature of space itself, then light following the straightest path through curved space should bend. During a solar eclipse, astronomers measured the positions of stars near the sun's edge. The stars appeared displaced from their true positions. The starlight had bent, passing near the sun, exactly as Einstein predicted. This is gravitational lensing. We see it in observations all the time. Now, massive objects bend light from more distant objects behind them, creating distorted images, direct evidence that space itself curves in the presence of mass. Astronauts in orbit look weightless, floating around. Zero gravity up there, right? Wrong. The gravitational field at the altitude of satellites, a couple hundred miles up, is almost as strong as here on Earth's surface, about 90% as strong. So why do astronauts float? Because they're falling. The capsule is falling. Everything is falling toward Earth constantly. But they're also moving sideways very fast, about 17,000 miles per hour. As they fall, Earth's curved surface falls away beneath them. They keep missing. They fall around Earth instead of into it. Everything falls together at exactly the same rate, so there's no sensation of falling, no weight, no sense of up or down. It feels exactly like floating in empty space, far from any mass. This is equivalence in action. Free fall in a gravitational field feels identical to floating freely in empty space, because they are the same thing. In free fall, no force acts on you. You're following the natural geometry of curved space-time. Think of Earth's surface. It's curved, but standing on it, it looks flat to you. And here's something remarkable. Why is Earth round in the first place? Because of gravity, but not in the way you think. It's not that some force is pulling everything toward the center, molding Earth into a sphere. It's that space-time around Earth's mass is curved equally in all directions. Every piece of rock, every drop of water is trying to follow the straightest path through that curved geometry. And when everything follows those curves from all directions equally, you get a sphere. The only shape where every point on the surface is the same distance from the center. Earth is round because that's what happens when matter follows curved space-time. The shape emerges naturally from the geometry. An ant walking what it thinks is a straight line on that curved surface actually follows a curve. But from the ant's perspective, it's going perfectly straight. That's what's happening with everything near Earth. Except it's not just space that's curved, it's space and time together, space-time. Massive objects create curves in space-time, depressions, wells, distortions. The sun creates a deep well, Earth creates a smaller one. Even you create a tiny well, too small to measure easily, but it's there. Objects moving near these wells naturally follow the curves, not because anything pulls them, because they're following the straightest possible paths through curved space-time. The moon orbits Earth because it's following the natural geometry of curved space around Earth. That geometry makes the straightest path into a circle. An apple falls because it's following curved space-time near Earth's surface. In that curved geometry, straight ahead through time points toward Earth's center. When you throw a ball, it follows a parabola.
not because gravity pulls it down, because it's moving through curved space-time, and the straight line in that curved space looks like a curve to you. You're standing right now. You feel weight. In Newton's picture, gravity pulls you down and the floor pushes you up. Two forces, balanced. In Einstein's picture, only one force acts on you, the floor pushing up. But if there's only one force, you should be accelerating, and you are. You're accelerating upward constantly. The natural path through space-time points toward Earth's center. That's the free-fall trajectory. But the floor is in your way. It pushes you upward, deflecting you from that natural path. You're like someone standing in an accelerating rocket. The floor pushes. You feel weight not from any downward pulling force, from being accelerated away from your natural path. The apple hanging in a tree is also being pushed upward by the branch. When the branch breaks, the pushing stops. The apple is finally free, free to follow its natural path through curved space-time. It falls. But the apple isn't accelerating. The apple is finally free to move naturally. You, standing on the ground, are being constantly accelerated upward by the floor pressing against your feet. Falling is the natural state. Standing still requires a force. That's Einstein's revolution. Once you understand gravity as geometry, extreme phenomena make sense. A star is essentially a massive ball of gas. Its mass creates a deep well in space-time. The natural paths in that curved space point inward. What prevents collapse? Pressure from nuclear reactions in the core, pushing outward. Balance. When the nuclear fuel runs out, the pressure drops. Balance breaks. The star collapses. If the star is massive enough, the collapse continues until matter is compressed to incredible density. Atomic nuclei merge. Electrons are crushed. What emerges is a neutron star. Nuclear matter compressed to city-sized. A teaspoon of this stuff would weigh 1 billion tons. For even more massive stars, not even neutron pressure can stop the collapse. Space-time curves so sharply that all possible paths lead inward. Even light cannot escape. This is a black hole. Near a black hole, space-time is so severely warped that light itself, following the straightest possible paths through this geometry, spirals inward and never comes out. We can't see black holes directly, but we see their effects. Matter falling toward a black hole speeds up, heats up, irradiates enormous energy before disappearing. All from one idea: mass curves space-time. Objects follow the curves. From this one principle, everything follows. Planetary orbits, tides, the precession of Mercury's perihelion, a tiny effect Newton's theory couldn't explain, but Einstein's predicts perfectly. Gravitational lensing, black holes, gravitational waves rippling through space when massive objects collide. The same principle explaining how the moon orbits Earth also explains the largest structures we observe: galaxies, clusters of galaxies, universal, elegant. The pattern in the small piece reveals the design of the whole fabric. Newton's equations work beautifully for practical purposes. We use them to launch satellites, calculate orbits, predict eclipses. They're simpler than Einstein's equations and accurate enough for most applications. But Einstein revealed what gravity actually is, not a mysterious force pulling objects together across empty space, the curvature of space and time themselves. Mass tells space how to curve. Curved space tells objects how to move. When you step on that scale, you're not measuring a downward pull. You're measuring how hard the scale must push to prevent you from following your natural path through curved space-time. When you watch something fall, you're seeing an object finally free to follow the geometry that mass has woven into the fabric of reality. When you look at the moon, you're seeing an object following the straightest possible path through the curved space around Earth, a path that looks like a circle because space itself is curved. Space, brim.